This is 8.3, all about the unit circle. So remember this question? This question where we have the diagram and it's a 30, 60, 90 triangle. And we need to find the coordinates of point D. We worked through this a couple lessons ago. All right, consider if we took this to another level. So instead of just having one triangle, imagine we had three. And not just any three triangles, but a 30, 60, 90, a 45, 45, 90, and then another 30, 60, 90, but in a different orientation, like this. Okay, so the angle created here, angle ABE, is 30 degrees. Angle ABD, that angle right there, that's a 45-degree angle. Okay, and then the other angle created, angle ABC, right here, that's a 60-degree angle. So we have three triangles. Okay, what's different about this question is that we're going to assume the circle's radius is 1. So let's do a little bit of thinking. Let's sketch each triangle and figure out what the coordinates of C, D, and E are. So we're trying to figure out what are these missing coordinates. Okay, so this is different from this last question because here we had a leg length. Now we have the hypotenuse length, which is 1 for each of these triangles. All right, so let's draw a rough sketch. They're going to be imperfect. First thing I'm going to do actually is put a bit of extra labels here. So that's going to be point F. This is going to be point G. And this will be point H. Okay. And then we can take this 30, 60, 90 triangle, which is F, B, E, and we're just going to kind of separate it out, give ourselves a little bit more space. Okay. And then let's bring out our 45, 45, 90 triangle. Again, this is a very rough sketch. Okay, and this is triangle, this is angle B, this is point G, and this is point D. And then put down here, we want our other 30, 60, 90 triangle, the taller one. It's just oriented a bit of a different way. B, H, and C. This is a right angle. This is 60 degrees. And we know that the hypotenuse of each triangle is 1. Okay? Because those circles' radius is 1. Each of these hypotenuse lengths is a radius. Okay? So now let's use our right triangle rules. So think about this for a second. See if you can do this without any guidance from me. Figure out as much as you know, and then stop when there's something that you don't know. Okay, if we were in a classroom right now, it would be much easier for us to progress through this as a thinking activity, but alas, we cannot. So the first thing you might have done is you might go through and label the rest of these angles, right? 30 degrees, 45 degrees, and 60 degrees. Okay, and then you might have tried to recall some sort of information related to, this is an isosceles right triangle, so we know that the shortest leg lengths are congruent. And then maybe you recall that this shortest side length could be written as an x, and in that case, then the other leg would be that side length times the square root of 3, which means the hypotenuse would be that length times 2. These are our special right triangle rules, and that also applies up here to our other right triangle, right? We could say that this is x, that this is x times root 3, and that this is 2 times x, because both of these triangles have hypotenuse 1. We could use the same variable to represent their missing side lengths. And then here, say that we label the leg y, the other leg would also be length y, meaning that this hypotenuse would be y times the square root of 2. Okay, those are all special right triangle rules. Okay, and so now what we can do is use the sides that have 2 different pieces of information, use the hypotenuse information to actually solve for these variables. Okay, So here we could say, y times the square root of 2 is the same thing as 1. Those are two equivalent ways of representing the hypotenuse length, meaning that y equals 1 divided by the square root of 2. Okay? To be in proper form, we should rationalize the denominator, we should multiply by root 2 over itself, meaning that y equals root 2 over 2, okay? And so what that means is that this point D has a value for its ordered pairs of square root of 2 over itself, or excuse me, square root of 2 over 2, comma, square root of 2 over 2, because that's the horizontal and the vertical distance. Okay, so point D has these coordinates, root 2 over 2, root 2 over 2. And then we really only need to work with either this diagram or the other one because we're trying to find the same value in both. Okay, so we could say, hey, this hypotenuse information, 2 times x is the same thing as 1, meaning that the shortest leg has a length of 1/2. This distance right here, right, would be 1/2. Okay, that's our vertical distance, so it's a 1/2 here. Meaning x times the square root of 3, 1/2 times the square root of 3 would just be the square root of 3 over 2. Okay, and that's this leg length right here. Square root of 3 over 2. And then for our other triangle down here, x again is 1/2, and then x root 3 is 1/2 times square root of 3. So point C has the same information, but the x's and y are just in different spots. Okay. So, what does this mean? What does this mean for us? So, say we got really excited, right, and then say we carried on this diagram. We did this in class. Say that we carried on each of these, let's see, each of these hypotenuses, say that we carried them on, right? And say that we maybe reflected each one. So if we reflect this triangle, right, we're going to end up with a really, really fun diagram. So all we're doing is we extended those lines, and then now we're starting to reflect these 3 triangles into quadrant 3. Okay, and so I reflected their legs first, and then now I'm going to connect the center to the intersection here of the outside of the circle and that leg, because that would be where the hypotenuse is. Okay, this is really, really cool stuff, guys. All right, this is a really sweet geometric construction, and then we will now continue these segments up into the other quadrant. Okay, so we end up with something that looks like this, and if we delete these 2 segments, there's 3 segments, excuse me, and then we end up with something called the unit circle. Okay, so picture we're taking those ordered pairs that we just found for points C, D, and E, and then this is going to have the same points as E, except we're in the negative x direction and the negative y direction, so both coordinates for x and y would be negative. All right, so we end up with negative root 3 over 2, comma, negative 1/2. And then what other segments did we get from E? We got this one as well, right? This is like E double prime if we just reflected it as well. And here we're in positive x territory and negative y territory, right? Because we started here. And then we're just reflecting it over. And we have this one over here too, E triple prime, right? This is just notation used to communicate reflections. All right, and we can, this should be a negative, we can repeat this process for all of our points. Okay, so this is how we are going to finish up today. So I'm going to choose my lines very carefully. I want to choose a line segment, and I'm going to choose a red color. All right, so let's see how we can do. This is going to be the side that our 30-degree angles go through. These are the ones I just labeled for us. All right, and they go through the center of the circle as well. And all of those, this is 30 degrees, and its x, y coordinates are square root of 3 over 2, comma 1/2. This over here, so 30, 60, 90, 120, 150. And its coordinates are negative square root of 3 over 2, comma 1/2. And then down here, 180, 210, 210 degrees. And its coordinates are negative square root of 3 over 2, comma negative 1/2. And then over here, 210, 240, 270, 300, 330. Okay, and then square root of 3 over 2, comma negative 1/2. Okay, before I get too far, let's go back and label our original axes. Okay. So right here, this point is either going to be 0 degrees, or if you've completed one full revolution around the circle, it'd be 360 degrees, but either way, it's going to have coordinates of 1, 0. Here, we're up at 90 degrees, or pi over 2, and its coordinates are over 0, up 1. Here, we're at 180 degrees, and our coordinates are negative 1, 0. And then here we're down at 270 degrees with coordinates 0, negative 1. Okay, let's keep going. You might have heard me counting by 30s, so let's go ahead and fill in our 60-degree angles now. All right, so then picture if we reflected this segment into the quadrant, we would be over here. Okay, and then now let's label our points. Okay, this is 60 degrees, and then for 60 and 30, the points are just flipped. 1/2, comma, square root of 3 over 2. 30, 60, 90, and then 90 plus 30 is going to be 120 degrees. And its coordinates are 1/2 root 3 over 2, but we just got to make sure that the negative is in the appropriate place for this quadrant. So we want negative 1/2, comma, root 3 over 2. So 120, 150, 180, 210. 210 plus 30 gives us 240 degrees down here. And then we're here negative x, negative y, so both are going to be negative. Negative 1/2, comma, negative root 3 over 2. 240, 270, 270 plus 30 is 300. And then we're in positive x territory and negative y territory. Almost done. Super close. Okay, what's left is our 45s. Okay? And when we label our 45-degree angles, and those that kind of match up with it, we start at 45. Okay? And then you can just take 45 plus 90, and that'll give you this point here. Okay, 45 plus 90 will give you 135. And then 45 plus 180 will give us 225. And then 135 plus 180 will give us 315. Okay, and for the coordinates here, it's going to be, this is really easy. It's root 2 over 2, comma, root 2 over 2. It's the same thing for both. We just got to get our positives and negatives in the right places. Okay, negative for the x, positive for the y's. And I recognize that at this point your diagram is probably pretty cluttered. Just do your best when you're writing this out. Do you have a fresh printed copy of the unit circle at the very, very back of your notes packet for a reference sheet, okay? So you can refer to that one if it's a little bit cleaner than your current drawing, okay? But this is really helpful, especially with the colors, to see everything that's going on. You don't need to memorize this right now. In the future, you may, okay, in pre-calc or calculus, you may have a teacher who wants you to memorize all this information as well as these degree measures in radians. But right now, I just want you to think about it, okay? Other things that you may need to know is that if it asks you a cosine of an angle, so cosine of 30, that's the x-coordinate of the 30-degree angle. So cosine of 30 would be like root 3 over 2, okay? Sine is the y-coordinate, so if you're asked what's sine of 45, you would find 45 on the unit circle, and you would give us the y-coordinate, which is root 2 over 2. This is how your calculator generates cosine, sine, and tangent. They use the unit circle. And then tangent, so if you're asked what is tangent of 315 degrees, okay, you take the y-coordinate and divide by x. So what's tangent of this would be negative root 2 over 2 divided by root 2 over 2 divided by itself, which would just end up being negative 1. Okay, so more to come on those things in the next section. For now, let's just sit with what the unit circle means. Check your practice and let me know what questions you have.